Y solo 2 segundos que voy a estar con eso. Venga, empezamos otra vez. Okay. Hello and welcome to the Arduino LiveCast. For some reason, we started streaming and the camera wasn't really on. So I spoke for a couple of minutes before I started. So we start again. So welcome to our livecast about the space exploration. As you know, 2019 is Arduino Education Space Year, and this today we're going to talk about an experiment we did last week in Spain, where we launched a couple of balloons up in the atmosphere, about 20 kilometers high, and we collected data about radiation, barometric pressure, and temperature, among other things. But this story is a story that has to be explained in a bit of a different way. It has to be explained from the perspective of the kids that participate in the experience. And I think it's very important that we take a look at it, and I think I will tell you the story so that we can eventually try to replicate the experiment and do it yourself. The important thing for me is that we managed to make a full experiment in my case, I had very little experience in this, but we were working by the hand of Andres Sabas, who is the founder of Electronic Cats, which is a small company in Aguascalientes, Mexico, that is specialized in doing this kind of low orbit space missions with balloons as an educational project. And so we happened to invite Andres to come to BET, the educational fair in London. And as I was explaining the story to the president of the Trilema Foundation, which is a foundation in Spain that helps out schools in trouble and helps them revamp their educational models and helps them economically and with other things. Carmen, who is the president, she said, like, it would be great if we could have this workshop about launching balloons in space at our schools in Soria. So we started to look at it, and thanks to the kind collaboration of a lot of people, volunteers and city councils that put money, and the school itself put some money, and we at Arduino help out putting some boards and some help with technical support and so on, we could launch this mission and do the things that I'm going to talk about right now. So first of all, as usual, I want to thank Carl and Josephine that helped me with these live casts, putting together slides and with mentoring and helping revamping the shed and making it look a slightly better program after program. But after that, let's get started with what we're about to here to talk about, which is this mission. So it's really cold in the shed today again, and so it's even hard to speak. But so we're talking about this group of kids. It's 50 kids from the school from Trilema in Soria that get introduced to the idea of making citizen experiments, citizen science, by the use of balloons and measuring the atmosphere. And for this experiment, we counted with the help not only of Andres, who came to help out with the technical aspects and explain how you have to build your own mission, how you put together the kits, and how you launch the balloons, but also with Maripaz Zorzano, who is a pretty famous scientist, Spanish scientist. And she came in and spoke to the kids about astrobiology and why it's important to measure the atmosphere and look at this data with different eyes and learn as much as we can. Also because it will help us understand the effects of, for example, things like global warming. And so together with them, with Andres and with Maripaz, we found a bunch of other people that help us out, and I will talk about them briefly. So everything started in Soria, and we went to meet the kids in Soria, where we taught them about how to build their own balloons, how to make parachutes, how to connect Arduino, in this case Arduino MKR 1300, which is Arduino with LoRa, to a computer, how to program it using MakeCode, how to make it communicate over LoRa to a different Arduino that will be capturing data and mapping the data. And then we started to consider the possibility of launching. It takes about 2 days from the moment you start with the kids to the moment they are ready to launch a balloon. So there's a lot of activities that need to run in parallel. On the one hand, as I said, you talk about how to build the satellites, how to build the parachutes, and so on and so forth. But also you have to try to predict the journey of the balloon. So there is a bunch of simulators you can use where you can try out different aspects of the balloon, like the weight of the balloon, of the payload you're going to carry, with like the Arduino, the batteries, the cameras, the sensors, whatever you're going to put in it, the size of the parachute, and the desired speed at which the balloon will be coming down to Earth, which would be at around 5 meters per second. You can imagine that's actually quite fast. And depending on the balloon, the process goes like this. You inflate the balloon with helium, it goes up in the atmosphere. At some point, the pressure is such that the balloon explodes, and then it starts falling, and therefore the parachute will unfold and will help the payload to safely land on Earth. So our mission was to launch as many balloons as we could and try to rescue them in order to analyze the data. And so far we're still working on analyzing the data, but I'm going to show you how the whole process went. So this is one of the simulations we did. And the way you simulate is that you put the data into an online simulator, you introduce all of the aspects of the balloon, size, payload, weight, and so on and so forth, and you say, I want my balloon to explode at approximately, 20,000 meters, and it tells you, okay, then you need to put this many cubic meters of helium in your balloon, and it gives you a map simulating how it's going to look like. In this case, we took the map and we imported the map data into Google Earth because we wanted to see like the surface of the Earth. And what you see here is the predicted trajectory of the balloon. And we were really, really worried because at the end of this trajectory, there was an airport. And if there is an airport, it means that your balloon is going to land in a landing line, and that's not okay. So according to the Spanish regulations, you can launch balloons as long as you respect some basic norms, and one of them is being over 8 kilometers away from an airport. And in this case, we were not. And so, so we ran simulations day and night for 2 weeks before coming to the kids. And then once we were with the kids, we were running more simulations. And then the kind of things you can do is to vary the amount of helium you put in the balloon so that it will explode sooner or later, depending on where you want to do it. And we were very lucky because the weather was really, really bad. Like in Soria, the region where the experiment was taking place, the week before the launch, it was -10, and there was a lot of snow. So we were prepared to look for balloons like with full gear, like in waterproof pants, waterproof jackets, like flashlights, everything. But the day of launching the balloon, the weather went crazy. The wind stopped, and we had over 20 degrees Celsius in the area we were looking for a balloon. So everything went like 180 degrees, and it was a fantastic day for this experiment. So we had two teams. One team was at the beginning of the mission, where in my image right now you can see on the left side it says balloon launch. So one team was there and was ready to launch the balloons, put the payloads, and let them go at like 9 in the morning, pretty early. And the other team that I was part of was waiting at the predicted landing location with radio equipment, trying to listen to the GPS inside the balloon so we could find where it was going to land and we could look for it. So it's very important. You are completely blind because in this huge blue sky, a tiny balloon or a tiny parachute is invisible. So it's impossible to see. It makes no sense to be there looking at it with binoculars, or you have to listen to it with radio, and you have to wait for it. So we had these balloons, these CanSats, that contain a Maker 1300, which is a board that has LoRa that allows for wireless communication over really long distances. In this case, we had over 20 kilometers of distance with full coverage of the mission. And the kids build the balloons, and here you see a picture of one of the balloons that was launched, which is that cylinder on the table. That has to be very sturdy because it's going to land really fast and it's going to touch ground. And we want the equipment to last. And for example, the Geiger counter has a small glass chamber, so it should be protected so it doesn't break. Or there's a camera that's going to be filming the experiment all the way. That blue circuit that you see on the table, if I'm not mistaken, is actually the Geiger counter that was installed inside one of the satellites. So This is another take, and there you see Andres working with the kids very closely and giving the last touches to the satellites. That other white box that you see on the desk, that's actually one of the CAN satellites. We call it CAN because it's supposed to be very tiny, but in this case they're very large. And actually size is, we believe, what saved this satellite. Let's continue. Here you see one of the parachutes, the orange parachute that belongs to the satellite that we rescued, that we managed to rescue. And it's made out of an umbrella. So the size is calculated given the weight of the payload. So the parachute will carry safely the satellite down at a certain speed. And here you see the balloons. And this is a tricky scenario because you have to inflate the balloons given the amount of helium that you got from the simulation before. And as I said, we're simulating up to the minute before launching because weather changes and so simulations change, and you have to have the right amount of helium in the balloon so that it explodes at the right height. And here you see the video of the kids launching the balloons. Let's take a look at it. This is this view from land. And we had another view that was taken from a drone that was brought by one of the volunteers. And as I said, I will later explain about the volunteers that really made our day during the mission. So let's take a look at the view from the drone, which is actually really beautiful. So if you ever launch a balloon, I recommend you get a drone with a camera because these views are priceless. So here you see Borovia, the village from the sky, and we chose Borovia for 2 reasons. One of them is that it's the last village before the mountain, and according to the winds, the balloons were going to fly over the mountains. We didn't want the balloons to end up on the mountain because it was going to be really hard to find them. And the second reason is because I have an observatory, the only observatory in the region. So it was a great opportunity for the kids to get to see the observatory, look through a telescope, talk to people that run in the place, and get to know a lot more about space. So it was a completely integrated activity that was really beautiful. So on the one hand, we had these kids and coming to this village, which is already by itself a great activity. And it was so exciting that the mayor of the village decided to finance the trip so that instead of the 50 kids that were participating in the experiment, they could bring 150 kids to run the experiment. So it was a really great initiative from Borovia's city mayor, or village mayor in this case. So this was the launch. And at the other side, we had a team of people that were waiting for the balloons to launch. And that's where I was. While the kids were looking at the balloons taking off, there was a bunch of people, and here you see Kike, one of the volunteers, who is a professor at the Zaragoza University, that we met at the university and started to discuss about how we're going to approach the problem of finding the balloons, And Kike has some experience. He's launched a couple of balloons together with a colleague of his that you can see in this picture. And he has some equipment using LoRa WAN that is really portable and really tiny. On our end, we were using Maker 1300 from Arduino with an antenna, and we were like monitoring data straight into a computer so we could see maps in real time. And he had this pocket equipment that he could carry around and we could use in magical ways. I also have to give some credit to my dad, because my dad, who is an antenna engineer, or antenna technician, sorry, he really wanted to join. So he came together with us, and I was installing the directional antennas we used to monitor the balloons. Thing is that as soon as the balloons were 200 meters up in the sky, they were high enough so that from our location we could measure their signals with our antenna. This is very important. That's the reason why we use LoRa and why we use Arduino Maker 1300, because with inexpensive antenna, barely like €100, we can cover most of the flight of the balloon as long as it's on the air. And this is Andres and me. Andres was at the launch, and then he drove real fast to join us to join Kike and me with looking for the balloons using antennas. And this is one of the antennas we use, one of the directional antennas. And as you see, we're very lucky with the weather. It was extremely sunny, and that was very, very cool. And this is how the search goes. You basically get signals from the balloons. You get signals from the GPS over radio, and you get signals from the measurements of radiation and other data. So you have all of the data already in your computer in case everything goes bad and you don't find the balloon. So finding the balloon is more of like a pride thing. Also, if you have a camera, you want to rescue the camera because you cannot send the high resolution pictures in real time over LoRa. The stream is not good enough. And so we were walking around in these valleys looking for balloons and trying to find them. We launched 2 balloons in total, and I will not anticipate how many we found, but we launched 2 balloons in total. One contained Geiger counter, which was a very important scientific experiment suggested by Luleå University from the north of Sweden to measure radiation of the near atmosphere. And the other one contained a camera to take cool pictures of the experiment. And this is how it looked like. So it was actually a really beautiful day. And if you get a chance to visit Aragon, I completely recommend it. So the balloons took off in Soria, which is one region, and they landed in Aragon, which is the neighbor region. This is another of the volunteers. This is Pablo, who is really well known because he is collaborating with an open source project called Escornafan, which makes open source robots based on Arduino Nano. And in his hand, he's carrying an omnidirectional antenna that was also used to look for signals. And he volunteered helping out. And actually, he's the one that brought the drone that took these beautiful aerial views of the launch, or eagle-eye views of the launch. But we didn't use that technology only in that way, because when we were looking for balloons, Kike had this idea of why not attaching his tiny LoRa receivers to the drone, because when the balloon is on Earth, it's very easy to get direct line of sight, so the signal is very easy to get inside the computer. But if let's say the balloon, the CanSat landed in some sort of like a valley, then the signal will not come straight out of that place. So, but if we have a drone flying with an antenna, then we can capture the signal from whatever it is and get the GPS signal again back in our system and then look for things easier. So this is an example of how this system was made. In this particular case, they were not really using the Maker 1300. You use an Arduino Micro with an external LoRa chip, because this is an old equipment that Kike built himself. But you could do that right now already with a Maker 1300. And here you see how the thing operated. So the kids from the Trilema Foundation, they were looking at stuff on the iPad that was controlling the whole video feed. So we were looking at balloons in different places using the drone. I have to say, unfortunately, this search with the drone didn't really work. I mean, we had some data from the GPS that was a lot more effective at that moment. This was a desperate attempt to find one of the balloons, because we did find one balloon, and we found it really, really soon. And this is a picture of the balloon, and you might recognize some of the elements from the previous video. So you see there is the orange parachute, and there is the big white box that contained the Geiger counter, the electronics, and a battery pack. And what we saw in the data is that this balloon fell real fast. It was supposed to fly down at 5 meters per second, but it flew down probably at 100 meters per second in the last 1,000 meters, which means that the parachute basically got tangled somehow, and it fell down like a stone. And just the size of the CanSat helped it so that it didn't go any faster. And actually, the electronics were intact. We could rescue all of the electronics and get out the Geiger counter, no problem. And so here you see a comparison of the simulation of the actual flight, where you see the intended flight, and then the red dots are the measurements we took of the geolocation of the CanSat. And you might ask, okay, what happens between the first half and the second half of these measurements? And it's actually a very easy explanation, because we trying to make an equipment that is or the guys of Electronic Arts tried to make an equipment that was as cheap as possible. So GPS signal is lost when it goes over a certain altitude. When it goes over 10,000 meters, it stops transmitting, but you still get LoRa signals, and you get things like the temperature. So we know that when the satellite was up there at like 16,000 meters high, the temperature was minus 31 degrees Celsius. So all of the electronics survived the whole process. They went from 0 degrees in Borovia up to minus 31 and up to over 20 when they landed. And they could make the whole journey, and they survived the whole experiment, which is actually quite impressive. And the most impressive thing for me is that the LoRa system kept transmitting all the way. So the data you see here is the data we have processed, which is only geolocation. But together with it, we have a map of radiation based on altitude, which is a very relevant scientific data that we want to analyze later. And that's been requested by Luleå University in the north of Sweden to make a scientific study. So our goal from now on is going to be to keep on measuring radiation in the atmosphere with these very inexpensive balloons. And if you are interested in participating, I invite you to take a look at the notes of this video, where you will find find more information on how to make these balloons, thanks to the help of electronic cats and Arduino. So this is the end of this, of bringing more stories of Arduino in space very soon. See you on the internet.